Thank you, Joanna, for the great introduction. I'm super excited to see so many of you in the webinar today. Not only I, but also the team is super excited to see so many interested in Haystack and in LLM-based agents. And today, in the next 35 minutes, I want to give you a, first of all, introduction into the concept, but also then a deep dive into some code snippets, how you can use agents in your applications. And I will also have an eye on the chat. So if you have some questions during the webinar, just ask us. The webinar is constructed consisting of 4 parts. So we'll start with the concepts of agents, but also the concept of tools. And in the second part, I will show you how you can add your own custom tool to an agent to extend the agent's functionality. And then in the third part of the webinar, we want to do an implementation deep dive. So I want to give you a first impression of all the different classes that work together within Haystack to make agents work. And finally, we want to talk a bit about the future of agents. So some very cutting edge features that are not even yet implemented on the main branch, but are open PRs and will soon be part of Haystack with the next release. And with that, I'd say let's jump right into what are agents. So essentially, I would say that agents are large language models with access to tools. So they consist of these 2 main components. An agent has a large language model that it can use to extract or generate language and also let's say process input user queries. And on the other hand, it has also access to tools, which it can then use to respond to the user queries. And the special thing about agents is also that they are instructed in a way that they usually follow a step-by-step thought process, so that they can handle also more complex user queries in a step-by-step process and, let's say, build up an answer until they can finally respond to the user query. And at each step of this thought process, they can select a tool. They can also choose what input they want to use with the tool. And then they can invoke this tool and again process its returned output. And in Haystack, that's quite simple to set up. So it's really as simple as what you see here. We can initialize an agent by giving it a prompt node. And I will show you in a second how to actually get a prompt node. Then as a second step, we can add a tool to an agent. And this can be like any pipeline or any component from Haystack. So here it's a web QA tool, and I will also show you how to do that. And then you already have an agent with a prompt node and a tool. So you can run this agent and put a user query into this. And this is probably also the right time to start with some code example. So let's have a look at this script here. We have some code already here because we want to use a tool, I said. And the starting point for a tool can be any pipeline you have in Haystack. So what I prepared today here is already a pipeline. And this is called a web QA pipeline. And this functionality is basically it can send questions to a search engine like Google or Bing, and then extract answers from the returned search results. But it's not really an agent because there's no large language model involved that does this step-by-step thinking. And this is what we want to do now. So basically, I said we need a prompt node, and let's come up with one. So an agent prompt node is a prompt node, and this is in Haystack the, let's say, abstraction of a language model together with instructions. So we basically say here which model we want to use, and this now is GPT 3.5 Turbo, which is behind the OpenAI API. This is why we also need to provide an OpenAI API key. Then we have max length. This is the number of tokens that we at max generate every time. And what we can also say here for prompt nodes is we can define stop words. And stop words are basically what we want the model to use as the final token it generates, let's say. So this could be, for us in this example, observation, and I will show you in a second why this is the case. Now that we have a prompt node, we can actually already create an agent. So we can say agent, and then we need to import this. And then we can say this uses the agent prompt node. So now we already have an agent, and we can now add a tool to this agent. But before we can actually do this, let me show you. So we can give this a name already. So we can call it maybe search, because what it will do is it will basically it will use the web to search the web for an answer to our question. And I just noticed what I did wrong. So before we can add a tool, we need to create a tool. So we need to create a tool, and we can also import that. And name is search. Then we have a pipeline or node, because as I said, any pipeline or any node, any component in Haystack can be a tool. So we here use now the pipeline we defined earlier. And then the last part is actually description, because every tool needs a description to tell the agent what this tool can be used for. So here we can say it's useful for when you need to Google questions. And now that we have this tool, we can actually add it. And then we can also run the agent. And one example question that I had in mind to showcase this was, what year was the creator of the Python programming language born exactly? So let's try this out. What I did before also is I generated these API keys, but you can also do that. And we have links in our documentation how to do that. And now we can already see an agent in action. So let's see what it actually does. So it generates some text, and we see the output here. And the model generates basically what it needs to do to answer this question. So it needs to know the name of the creator of Python first. And for that, it decides to call the search tool. And it calls the search tool with some input, which is basically now a search query for a search engine. So Python programming language creator is the input to the search tool, which is our web QA pipeline in this case. Then it finds the name of this person. And the agent now does another step of its thought process, basically saying, okay, now I need to know the birth year of this person. And because our agent right now has only one tool, the choice selection is kind of simple. We say, okay, we need another run with the search tool. And now we use a different search query, find the year of the birth of that person, and have the final answer. So this is the first example. So I very briefly mentioned that agents have a prompt node, and the prompt node is the combination, let's say, of a large language model with some instructions. And you wonder now maybe how we can actually instruct large language models. And this is where the prompt template comes into play. So prompt templates contain instructions for a large language model. And in fact, when we generate an agent or when we initialize an agent, we need to define always a prompt node. And this is what I also did in the script I shared with you. But what we don't need to do, which is just optional, is to specify a prompt template, because there's a default 0-shot React prompt template. And these are instructions for the agent how to work. And I want to give you a look at this. So this is what the prompt template in Haystack actually looks that is called 0-shot React. And we can make this a bit more readable. So this is what the large language model gets as input for the start. And I'll read out some of the parts. So we start the instructions to this large language model, which acts as an agent for us, with the following. You are a helpful and knowledgeable agent. And to achieve your goal of answering complex questions correctly, you have access to the following tools. And then already we have a placeholder, because this prompt template is a template that we can fill at runtime with the tool names that the agent has access to. So in our case, this would just be a search. It has just access to one tool right now. And then we continue with instructions and say, okay, to answer any question that is given from the user, you will need to go through multiple steps involving step-by-step thinking, selecting appropriate tools, and so on and so on. And when you're ready for a final answer, you need to respond with final answer. And then we define a format that helps the agent, this large language model, to always be, let's say, more reliable, because it has this strict format to follow. So it doesn't just generate any text. We instruct it to always follow this format, which helps also the step-by-step thinking process. So we say, okay, it starts with a question. Then you need to generate a thought. Then you can pick a tool, for example, search. Then you can come up with the input for the tool. This was the search query sent to the search engine. And observation is then the returned output from the tool. And at some point, this is why we have a ... At some point, after some iterations, you have a final answer. So you also need to generate this text and say final answer, and then give the final answer to the question. And we can even instruct the model to be very short. This is just one way, though, how to instruct models and large language models. I want to show you another example of a prompt template for an agent, which is the few-shot React template. So up to now, we had zero-shot React, and now we do few-shot React. So the zero-shot React we had here had no examples for the agent in the prompt template. But the few-shot React template is the following. It starts very similarly with these instructions that the agent is helpful and knowledgeable, and that it can choose between different tools. But then we actually give some examples of user interactions. So in the instructions, we provide examples of how the agent should usually interact. So we give a question, a thought, and the tool the agent should usually pick for that kind of thought, what kind of input it should generate, what may be the observation then, what it could be, and so on and so on. And we even show the language model what the final answer then would be. And we can continue this multiple times, so we can actually give multiple examples. And you will see how this then changes the results. The rest is still the same. So the only difference is that now when we create and initialize our agent, we have a prompt template that we pass to it, which is the text I just showed you. And then we have a prompt node for our tool. We define our tool, we add the tool, and we run the agent. So having a look at the output before, you see that the questions, for example, were quite short, like keyword search queries. And when we run this few-shot example now, you will see that with slightly different instructions, also the text that the model generates is quite different. So now it generates, let's think step by step. And to answer this question, I need to know who the creator of Python programming language is first. So again, we first search for the name, but the tool input now that we send to the search engine is actually a natural language question, a real sentence. And also the thought from the model is more, let's say, about reasoning. And again, we get in the end the final answer to this. So let me again walk you through the step-by-step process to make sure that we're on the same page about what the agent actually does and that there's no magic involved here. So we start with a question: what year was the creator of Python programming language born? And then the agent needs to generate some text, and it's instructed to generate a thought. So some, let's say, reasoning, what needs to be done next. And it generates the thought, okay, first I need to find out who the creator is. Then it generates more text and is instructed to generate a tool name and also the input to this tool. So this question, who is the creator of the Python programming language? The first step to get the answer to this user question. And then it invokes this tool. It invokes the web search. Having this answer to the first thought, now the agent is instructed again to generate a thought, so to do some reasoning. And for that, it generates the text. Now that I know that this person is the creator of Python, I need to find out when he was born. And at that point, the agent can again pick between different tools or choose from different tools. In this example, it has only one tool, so it picks the search tool and then asks the question about the birth date or about the year, comes up with the year. And then again, the agent with this information is instructed to reason. And now it says, okay, I know the final answer, and it returns the final answer. So this is one entire run through the agent. And the difference is really just these two prompt templates. And I hope now with these example scripts, you saw that if you want to play around with agents, it's very simple to just make slight changes to the prompt template, which is called prompt engineering then, because this affects what the model does. And you can step-by-step optimize and see what works well and maybe what you need to change. So for example, what's important also for the wording is how you name the tool, because this gives some instruction or some direction to the model what this tool is useful for. And similarly, the sentence where we wrote, okay, this tool is useful for when you need to search the web. This tool description is also important and part then of this prompt and part of the prompt engineering. And both of these have still like the same goal in mind, right? So in the end, the agent is there to get a user query, and in multiple steps, you could call them multiple hops, answer a user query. And this is actually why this application is called multi-hop question answering, because you can do multiple sub-questions. Okay, so let's see where we can answer some questions live. Tuana, anything?
Hey, there are quite a few questions already. I'm mentally grouped some of them because some of them are quite related to each other. So I want to start from the top. There were already quite a few questions around, are there any open source large language models that we could use with this? Are there any plans to support with non-open AI models like the Llama family, etc.?
Yeah, I can answer that. So we have support for some models already. Most of them you still probably don't want to run on your own machine. Some of them, yes. We're exploring new models every week. I mean, not models developed by us, but developed by the open source community. And we're comparing them. And the final slide, I think I have also the name of the model, but also in the notebook I will show later, we can see one alternative model. One alternative is to use models hosted by Hugging Face Transformers, for example, and run it from there. Yes. You might want to slightly change then again the prompt, right, and see what works well with this particular model. But in general, we are exploring all these models every week, and we will also share it in the documentation when we find other models as alternatives to OpenAI.
And then I want to ask at least 2 or 3 more that I'm seeing here, because I think they're again quite relevant to what you were going through. What is the maximum length of the prompt to ask the agent? And then I think somewhat relevant to that, there was also another one, maybe not exactly the same question, but it's known that supplying examples in the prompt limits the ability to generalize. What are your thoughts, and are there any specific use cases where the few-shot approach is especially useful? So this is all about prompt style and prompt length.
Yes. So maybe let me answer the last question first about when to use the few-shot and what's important for that. So I think when you create these few-shot examples in this prompt template and you give multiple ones, you need to make sure that they are diverse, right? And this maybe helps also the model to generalize. So if you, let's say, have a prompt template that is mostly for showing the agent when to use which tool, and you have an agent that has access to 5 tools, I would suggest to also have like 5 examples in this few-shot prompt template, and one for each tool you have, so that the agent from the examples can understand a bit when to use which tool, basically. And I think when are these few short examples especially helpful? So for us, we noticed that they are like always so far very helpful because it's more predictable what the model does. And this is maybe, I don't know, slightly controversial given that you said we want them to generalize well, right? Because in applications, we oftentimes also want to be able to know what the agent will do, right? We don't want to be as much surprised. So one example is if we don't give too many few short examples here and just tell the agent, okay, just go ahead, you have 5 tools. Sometimes it happens that the agent makes up a 6th tool or a 7th tool. And then when we ask it to come up with a thought, it's a reasonable thought. And then it says, okay, I want to now not use the search tool, but maybe I want to use now Bing, or I want to use Google. And as we have no tool with that name registered for the agent, it just breaks at this point. Or maybe even some other tool name. Maybe it wants to ask the expert for Python programming languages, right? Maybe the agent makes up, I want to ask an agent expert for Python.
Yeah, there was the next follow-up to that, the maximum length of the prompt to ask the agent.
Yeah, depends on the model, honestly. So we also see from week to week that the number of tokens you can use with these models increases. It's a factor for the cost though, right? So the longer you make these templates, the more tokens you also send to the model, which makes it more expensive if you use APIs.
I'll ask one more, and I think I'll hand it back to you because we're slowly running out of time, I think. I'll group 2 more questions together, which I think are related to each other. One is, how does the agent know it has arrived at a final answer and stop the iteration? And the other is, how deep can the trail of thought go? E.g., how do we ensure we can handle a question such as, what was the top 1 song when the creator of Python was born?
Yeah. So how does it know the final answer? Well, the agent can process the entire input then here at once, right? So all these tokens, they fit into, let's say, one processing step. So the agent at the same time has this thought. We've learned that this name is, this person's title is super middleweight, for example. And at the same time, it has this question, Anthony is the brother of which super middleweight title holder? So with that information, if you have these 2 sentences, it's not too hard for the agent to reason that it has the final answer. So I think that's part of the explanation how it comes up with. You could imagine it as just another tool, maybe. So the agent can choose whether it wants to use another tool or whether it knows the final answer, right? So whether it makes more sense to now say again, tool search and then come up with some question, or whether it's fair to say, I know the final answer.
Yeah, the follow-up, I think, was how deep can the trail of thought go? And I think we have a maximum iteration that we can also set.
Exactly. I showed this figure with the number or with the iterations. And there we can just say, okay, maximum 8 iterations are allowed, something like this. And if the agent then does not find the answer, we need to return, okay, couldn't find the answer. Cool. Okay, so I'll continue here and I'll try to speed some things up because now you saw this search tool, and the search tool was a pipeline we have in Haystack, right? This web QA pipeline. And this QA pipeline you could also use without an agent. Right? If you have a user query and want to maybe build, I don't know, a search bar on a website around it, you can just use this. But maybe you all want to add your own tool. So you're wondering, okay, I want to make agents use, I don't know, some API I have in mind. And I want to give you an example how you can build your own tool in Haystack. And where also the tools manager comes into play. So this is a short example here of the tool we saw. And for any tool you build yourself, it's always the same. You will need to come up with a name, which is the token that the agent generates when it wants to choose this tool and wants to invoke it. Then you have a pipeline or node, so a component in Haystack. And this is where you need to, what you need to wrap your custom tool in. in this pipeline or node. And then you need to describe to the agent what is this useful for. And this output variable is how the tool actually returns the result, basically. But we also have a default value for that. And the tools manager, I didn't mention so far, but this is easier to use if you have many, many tools. Because if you initialize an agent, you can also provide this tools manager, which is essentially a list of all the tools the agent has access to. So if you, let's say, have 5 tools, you don't need to call add tool, add tool, add tool 5 times. You can all put them in the list here. And with that, I think we should have a look at another notebook. So, let's reconnect this and run this, and I can explain to you what happens here. So basically, I had the idea to provide the agent with a custom tool, and the setup until there is the same as we saw earlier. So we have first here in this Colab notebook, we need to install Haystack. And then we need to, in a second, enter our API key. We create a prompt node using this API, and then we have our agent. And then what I thought here, why can't they use a tool that is actually a transformers tool and make this work with an Haystack agent? So there's also a tool class in transformers, and we call them here transformers tool. And what we can do there is we can basically load a tool from there, which is essentially a Python function. And this function, what it does is it goes to the Hugging Face model hub, and for a given task name, like text to video or question answering or text classification, it looks up the most popular tool on the model hub by the number of downloads. So we can now give this tool to an agent and enable the agent basically to search for tools for models on the Hugging Face model hub. And what we need to do for that is we need to wrap that in a component, in a base component in Haystack. So we basically need to tell what is it that we want to do when we initialize this component. And I said, okay, we need to provide this tool ID, which is basically where we can look up this tool from the hub. And then we load the tool. And then when the agent wants to run this tool, we just invoke the tool, we call the tool with a query that we give as input. And that's it. So this is our run method. And maybe for some use cases, we also want a run batch method. So if we have multiple queries at the same time, we just call run query multiple times. And now with that, I can initialize this component and say, okay, I want to have this component now in Haystack that uses this transformers tool. So now we have a node in Haystack, say, and we can even run this now in Haystack. And we can find out if I have the task text to video, the most popular model by number of downloads is this one. Now, if we want to give this tool to an agent, we also need to give the agent the name of the tool, like search we had earlier. Now this time it's maybe a model expert or something like that. And we need to give it this pipeline or node. And then we also need to give a description. And interestingly, we all have this also on the hub. So we can take it from where it's shipped when we load the model. We can add this to the agent and then run the agent. And this is what we see here. So now I can just call the agent, say, agent, what is the most popular model for the task of text to video? And it says, okay, I need to use a tool to see what the most popular model is. So this is, again, the 0-shot React template, by the way, because we didn't specify any other thing. So it chooses the tool. This is the name of the tool. The tool input is just this. And then we have a name. And I noticed when I tried this out, sometimes it doesn't work. So maybe with a slightly different question, maybe we can break it. And I can show you then how we can resolve the problem. So if I give another task, for example, I can basically create another tool. So let's reset the agent. Let's create a new tool. Now, Actually, we don't need to create a new tool, right? Let me first see where we can break this thing now. Question answering this set. Okay, so it breaks. It's unclear why, right? So we have the tool model download counter is the same name as before. We have a tool input, which looks like formatted in the right way, but somehow it doesn't work. And what you would do now, if you're building your application, you would probably look into the description of the tool and what output the tool gave, and so on and so on. So just to show you an example of a slightly different input there, yes, then I can give a different description of the tool and experiment with that. And now if I have a different description of the tool, what I do here is I recreate the agent, and then I recreate a tool now with a slightly different description. I can add the tool. Maybe let's first try again with text to video. And now I gave a different name here. You see model expert. And we have some interesting behavior here. So for example, the agent generates the right answer, right? It has this observation. But we also see then the agent does not reason as the final answer. It says, okay, I have this model now, but I still somehow need to check again whether this is really the most popular model. And then what it does basically, because it has no other tools, it calls the agent again, gets the same answer, and then says, okay, now I check the results. I can confirm this is the final answer. So this is maybe also interesting and shows a bit how the prompt engineering and how this agent reasoning is a bit not very robust yet, let's say. So now I have it also with question answering, and now also with question answering, it works. So it says, okay, observation, the most popular tool there is this Roberto-based squad. And now it also is faster in saying, okay, the final answer is this. Okay, so this was the part where I wanted to show you how easy it is to create a custom tool. Basically, we now wrapped the API to the model hub with this particular part of the API, finding the most popular model in a Haystack node, and then made it a tool with a description and gave it to an agent. Maybe to Anna, this is the right point in time already to get another question or two questions.
There are plenty. So again, I'll group some together. Because I think this came before, and I was waiting for you to share this collab because you had a demonstration of that anyway. The question was, is it possible that a large language model hallucinates or uses information not fetched from our tool? How are setting those ground rules to let it perform only using our tools? So I guess, how can we set the ground rules?
Yes. You can set the ground rules in the instructions, right? So in the prompt template, you can phrase the prompt template in the way that you clearly instruct the model. The set of tools you have is only this and nothing else. So you can also say something like cheating is not allowed, for example, to prevent the model from hallucinating. So these are things that work well in practice, honestly. We saw with some examples also that sometimes these models hallucinate when it comes to the tool name. So if they don't have the right tool at hand for a given question, they make up that there is a tool that they can also access and say, okay, for this question, I now want to ask this tool, although they don't have access to. And then right after tool input, it breaks because they try to run a tool that they don't have access to. So things like this. Later on in the presentation, I can show you what we call a self-reflection module that can also help with hallucination.
The next question Well, I think I'm going to skip to this one because I find it to be a very interesting question. Can we have an asynchronous tool and there's an edit or an interactive tool rather than async, meaning I want to trigger a QA agent as a subtool that interacts with the user to give back the response to the agent that triggered it. So a tool that can expect user input is how I'm sort of imagining it.
Yes, we can do that. I mean, we have a conversational agent that I want to show later today, right? So this is already very interactive, but you're free how you implement these tools under the hood, right? You could even, I don't know, after you return some intermediate answer to the agent, your tool could continue doing something, right? You could schedule something that the tool continue to do in the background, maybe. I don't know. Yes, it's very, very flexible.
I'll ask one more because I think it's a good opportunity to discuss how other Haystack pipelines can be tools themselves, because the question is, if the large language model that we are using may not have updated data as of today, can we use a vector database to support our model's answer to the question? If yes, how do we do that? Yeah.
Yes, you would do that by giving the language model not only maybe this web search QA tool that I gave, right, which basically can search the web, and we see more examples later on in the presentation, but you can also provide as another tool your private database or your company's database that is not publicly available. And then the agent can also access this database, this document store, to answer questions. You could even define a priority, like the order in which the agent should ask the different knowledge sources. Maybe first try your company's information in your company's document store. And if it can't find any answer in there, then use the web QA pipeline. So it's also a very flexible, the agent is a very flexible means to connect different knowledge sources, you could say.
Right, I think I'm going to give it back to you. We still have more questions, but I can ask them at the end too when we have time.
Yeah, let's try to speed this up. What I wanted to show you next is basically the integrations, because of course, now that you probably are thinking about what tools you can build, keep in mind the community, right? Others are building tools too. Others want to use tools too. So we encourage all of you to share the tools that you build. And for that, we have an integrations page on our website that is connected to a GitHub repository. So whenever you create a tool that you think is helpful also for others, you can make a pull request to this repository, and Tuana just shared the link in the chat. And then you can share with the community. We can also then have descriptions of these tools. And the idea is that on this integrations page, you can then search for different agent tools for different use cases. And of course, we will also extend the functionality in Haystack to increase compatibility with tools maybe you find in LangChain, or tools you find with Transformers agent and Transformers tools. So this is the GitHub repository. Yes, I wanted to give you next some implementation deep dive. Let's see, for time reasons, what we can do and what makes most sense. So I've collected a list of some classes here, and where we can talk a bit about what's most interesting to you and how they are connected. So you saw agent and prompt node are the things you need in the very beginning, right? So even with the first example, when you use an agent, you need an agent and a prompt node. And I said, okay, the agent combines a large language model, which is basically the prompt node with instructions, and the instructions live in a prompt template, but we have a default for that. Combines it with the large language model with the tools. So you can create different tools, which in Haystack are pipelines or nodes. And the tools manager you can use if it makes it easier for you to handle a large number of tools for the agent. A pipeline and the base component in Haystack, they can be tools. If they take text as input, basically a user query as input, and then also provide text as output. Agent step is some internal feature, but it's interesting to know if you want to extend really the agent implementation. So you're not only thinking about adding more and more tools, but maybe you want to change how the agent behaves, how this step-by-step thought process works. So this is maybe for more advanced applications. And then I have some really cutting edge features that I want to share with you today, definitely, which is conversational agent and conversational agent with tools, but also conversation memory, and then conversation summary memory. And also this default self-reflection that I mentioned as a means to prevent hallucination or to mitigate hallucination. And I'm thinking I'll show you some more code examples in Python notebooks, and maybe this can start a conversation, and then you can also try this out later. So let's see. Maybe this is a good first example. So what we're doing here is we use a conversational agent, which is a slightly different kind of agent, but you can probably already guess what it does. And it's right now living on a branch in the GitHub repository, so not on the main branch, but on the agents_version3_demo branch. I also have a link in the end of the presentation. And we implemented a couple of new classes for this agent that will be part of the next release. For example, the conversational agent, which is a little bit like a chatbot, you could say, right? So we have this agent, and you can basically ask follow-up questions to that agent. And while this is installing, I can show you the code down here. So when we want to create a conversational agent, very similar to what we had before, we need a prompt node. And here again, I'll use the GPT 3.5 Turbo model, but you could also pick other models. For example, we have this Open Assistant Pythia model for the people who asked for OpenAI alternatives. And you can use them also with inference provider, with the API inference from Hugging Face, for example. And then what we do in the while loop, we basically wait for user input. And whenever we get the user input, we paste it to the agent. So once we set this up, we can basically start with questions. And you can now interact with the agent, but now we use just the language model. So this agent has no tools yet. Still, it's a large language model, so it has seen a lot of information. I can, for example, ask, when did the Berlin Wall fall? And because this appears in the training data, right, it knows the right answer. And now I can ask follow-up questions. So I can say, for example, what did lead to this event? And the agent now knows that this event refers to the previous sentence and can give a response in the next iteration that is relevant to this question and fits this question, right? So I don't need to always say, okay, what did lead to the fall of the Berlin Wall? But I can really follow here. And we could even, I don't know, continue with a combination of factors, including political, economic pressures. Could you please elaborate on the economic pressures? And then you can continue this conversation with an agent, basically. So this is a first example. And before we jump into questions that you might have about this, I want to show you then the extension of this already, because the obvious next step, the natural next step, I think, is to have now conversational agents that also have access to tools. And this we can have a look at here. So again, this is on the same branch. And we have some more classes that we need now. For example, conversational agent with tools. And to the memory will come in a second. We have a few shot prompt here that we don't need to dive deeper now, but we, after the presentation or tomorrow, we can share the slides, and I can also share the scripts and the links to the notebooks. Basically, we're telling the agent that it now is a chatbot that has access to tools, so slightly different. And we tell the agent, okay, there's a conversation history tool now, because to work like a chatbot, the agent needs to be able to access the conversation history. And then we have our conversational agent here. And I have some questions. While I was installing, I can maybe take a first question to Anna. If there's any. If not, then I can also continue here.
Oh no, we have many. All right. Let's start from this one that I kept from last time. How does the temperature affect the stability of selecting tools by large language models? Is it better to go with a lower temperature or higher?
So I mean, with the temperature, you can basically influence how, like, maybe how predictable the model output is, or how let's say, I don't know, creative the model is allowed to be, right? And I think there it depends on the application. So if you have only a few tools, I don't expect this to be a problem, honestly, right? So if you have just a few tools and you have a good description of how the tools differ, so this is where the description string comes into play, then I don't think this should be a problem. Maybe if you have more and more tools, but then honestly, I would work more with the tool description still and try to optimize them. Maybe you can even use the agent or this conversational agent that I had and ask it a bit about what makes it difficult to distinguish two tools, and then better learn how this large language model sees these two tools as different. Because with the temperature, you also change, for example, how the tool input is generated, right? So then maybe there the language model also becomes more creative and, I don't know, comes up with some things that don't work well, or at least it's not robust or reproducible enough anymore. So then maybe one time I run it here in the tutorial and it works, and then I run it the second time and it does something completely different, right? So with a high temperature, you would have this ever-changing behavior. And for application in practice, I think oftentimes you want this reproducibility. Otherwise, it will also be hard to debug things if they don't work well in practice. Okay,
right,
so
I'm going to ask one more if you have time, because there's two questions again that are quite similar. And okay. I'd like to hear your answers to this actually, because I don't know yet with our implementation if this is going to be possible. One of them is phrased as, can we club multiple agents together? And the other is asking, can we create multiple agents and pass results between them? Sort of like, I'm imagining the way our pipeline passes data from each node to another node, kind of like the baby AGI paper that you've said.
Yeah, it's a very nice idea. It's like a little bit the idea of, if you have in machine learning a good model, but you cannot further improve it, right? Maybe you can make an ensemble of multiple of these models. And similarly, yes, you can think, okay, I have now this one agent. Why can't I use multiple agents and they work together? The question is, where is this useful, right? In what use cases is this beneficial? So maybe you want to have agents have a little discussion, maybe which tool to use next. So there you can basically force the model to reason a bit. But the thing is, if you use the same model, there's no real, I think, good reason why you have two agents then, right? You can like simulate the agent talking to itself also with just one agent. So this is maybe not really the use case. I think if you have agents that each of them have different skills. So one agent maybe is very skilled in anything about music. Maybe it has a Spotify tool and it can search there. Maybe it has access to the Wikipedia subset, everything about music, and maybe also a pipeline that you have with your private music library. I don't know. Then you have this agent, and it's the expert for everything about music. And then maybe you have another agent, expert in something else. Then I think it starts to make sense to combine them. But obviously, it also becomes more and more difficult to evaluate or difficult to debug this in. let's jump back to this conversational agent for a second.
I'll mute myself again.
So what we have here now is a conversational agent that has access to tools. And the tool that we have here is, again, the WebQA tool, you know, from the very beginning of this webinar. But also we have a conversation history tool. And let's start with some questions, and then I can tell you what this tool basically is. So if we have a conversational agent, the agent needs to keep track of the conversation. And whenever we have another user input, we also want to take into account the conversation history, right? But we also mentioned in the webinar today already that there's a limit in the number of tokens you can pass to an agent. We're not at the limit yet, but the longer I can continue this conversation, the closer we will get to this limit. At some point, it will just be too much. And the default with a standard agent would be that it just either throws away parts of the conversation or it breaks completely. And the idea now of this memory here with the conversation history tool and the conversation summary memory that we have here is that once in a while, maybe every 3 user questions, every 3 user queries as input, we want to summarize what happened so far in the conversation. So we want to basically compress the memory. We take the questions that we had so far and summarize this, and then we can store this in a smaller amount of tokens. And we can continue doing this and doing this. And if we do it for a very long time, at some point we need to compress so much that maybe some information gets lost. But this is quite natural also for memory, right? Maybe not your hard disk drive, but for our own memory, that the more information you store, at some point you will also lose some memory. So let's have a look into this conversation maybe and see what the memory does. So we have a question that you can only answer with accessing the web, because it was a recent news event from a few weeks ago now, I think. So we asked about this person, Jamie Foxx, who was hospitalized, and we can ask some follow-up questions. So we can ask after this short conversation about why he was hospitalized, where he was hospitalized. And because this is an actor, we can also then ask what movie was he filming at the time of hospitalization. So I think we have a final answer now. Yes, the model thinks the same. The final answer is this. Okay, so hospitalized in Chicago. Let me ask one more question, and then we can have a look at the memory maybe. So we have one function in this while loop here. If I say memory, this is actually not handled as an input to the agent, but it is like a small debug function that basically shows us what the agent right now has in memory. So we asked about the movie, and the search tool now tells us that he was not filming a movie. Okay, he was filming Back in Action in Atlanta. Interesting reasoning, I mean. So here we have a memory. And this is now what the agent stored in its memory about the conversation so far, which is a compressed version of the conversation. And it says, okay, human asked where Jamie Foxx was hospitalized. AI finds out he was in a physical rehab facility in Chicago. Human asked about movie he was filming, Back in Action. So this part about Chicago, for example, is very, very much compressed here, right, in this one sentence. And the way how we compress this is also very interesting, because it's just another prompt. It's just another prompt template where we told the model, okay, if you want to memorize something, you need to use this prompt. And maybe I can also show it to you here. I think here it is, let me see, where do I have it? So this is the description of the tool, conversation summary memory. It's just a tool. And we tell the agent, okay, this is useful for when you need to remember what you've already discussed. And we can jump into the code to have a look. Conversation summary memory. So it uses a prompt template, conversational summary. And if we want to have a look at that, we can basically go to the prompt templates in the code base. And there we have a prompt template called conversational summary. And there we can read the instructions that were used for the conversation memory tool. So the prompt text is condense the following chat transcript by shortening and summarizing the content without losing important information. Then we have a placeholder for the chat transcript. And then we further direct the model what to do next by giving the first few tokens of condensed transcript, which is basically this part. We say condensed transcript, and this helps the model to really start with the transcript after this exactly. Okay, so this is what the model does internally to compress and to have this information at hand. If I now ask further questions, it will connect my question with the things we have in memory. So if I ask now, when was he hospitalized, then the he refers to Jamie Foxx, and this is what the model finds out because it has the memory and the user query concatenated as input. And with that, we can take another question maybe. And we're also very close to the end of the presentation. So what I wanted to show you basically was from here, just the future of agents. Some parts I already covered. Now you can ask follow-up questions, right, together with web search. So what we had in the very beginning, you have web search now, but in like a chatbot, and a chatbot that also remembers what you ask and can compress this, and you can add even more tools. And the self-reflection module is basically another tool or some mechanism, you could say, where the agent from time to time can say, or generate a thought saying, did I do everything correctly here? Let me double check. Something is off here. I was able to find this answer, but then I did a mistake. I didn't do this and that. And this, again, we can direct with some instructions. And then the self-reflection module can also instruct the model how to pick up again at the right point. So when it notices it did some mistake, for example, it can roll back and say, okay, I basically used the wrong input question for the right tool. Or maybe it can say, it was actually the wrong tool. I should have used a different tool instead. So this is a thing that self-reflection module helps. And it's part of the notebook actually. So if we can trick the model into doing something wrong, we might even see the self-reflection model in action. And other than that, I have some links in the slides that you can use later when you get access to the slides. Any more questions to Anna that we have at this point? Probably yes.
Yes, and there's some that I kept from the beginning. We're a bit over the hour, so I'm going to pick a few. And for those who I haven't asked the questions to Julian for, please, I encourage you to join our Discord. Feel free to ask us anything there. But so that we're within the theme of agents and these tools, I do have a few that I can ask you here. One is, this is an interesting one. How do you evaluate the agent responses and detect if they are drifting?
They are drifting. Okay, so interesting. Yeah, so this is something we work on right now. And essentially, it's a generative question answering, parts of it at least, right? Because you have a user query and then you generate a response and you want to check whether the response was correct. One challenge, though, for evaluating agents is that there might be many different correct paths to the correct answer, right? So if you have multiple tools, maybe the agent can use them in a slightly different order and still at the end come to the right answer. I think one way right now, the most naive way would be to just check the final answer. You remember this example with the multi-hop question answering we had in the very beginning, where the final answer was just a year number. And this we can already automatically evaluate right now. So multi-hop question answering data sets you can use with agents. Whether the agent drifts, I'm not sure what's meant by drifting here. So drifting in the sense that you have a very long conversation maybe, and the agent starts to forget stuff. So this could be drifting. That it gets...
I read it more like going off topic, maybe.
Okay.
In a way, that's how I interpreted it.
Going off topic. So, I mean, if you have an interactive agent, like a conversational agent, you could maybe do evaluation with users actually and see whether they drop out of the conversation or how they respond to this. So you can really get live evaluation feedback. If you don't have a conversational agent, I would go for this, so for these evaluation data sets that I mentioned before, where you check whether the generated answer is semantically similar to what you expected. So you would need to create some labeled data actually. We are also working on evaluation means for hallucinations. So you can come up with some models that are good at detecting hallucination. And then you have a model that can be used for evaluating agents basically. And do some, let's say, for example, natural language inference and see whether the assumptions of the model are actually backed up by the input it had before, things like that.
I will ask one more question then, because it really sums up the whole theme here. Could you please give examples where you would use different tools within the same agent?
Yeah, if you want to combine information, for example, or information sources, right? So I showed you a tool that finds out the most popular model on the hub for a given task, right? But still it was reliant on the user already providing the task. And now another tool could be one that can map a user description of a task to this set of tasks defined on the hub, for example, right? So that knows the description of what is text classification, what is question answering, what is text to video. So you have one tool that gets the user description of a task. Then you have another tool that, given this task name, can find the most popular model. And maybe you want to have another tool that can actually load this model from the model hub and can actually run this model maybe. And then you can really have an agent that is somehow autonomous in responding to very complex user queries. So one vision could be you say, oh, I want to translate this text to some language, and you provide the text. And then the agent could say, okay, let me first check on the model hub, the most popular tool for translating from English to French, let's say, if this was your task. Then you find this model. Next, the agent can decide, okay, now I need to really load this model and run it. And this could be very powerful. And then you could also envision agents that at runtime can add tools to their toolbox, right? So if you have something like a tool hub or the Haystack integrations page, maybe you can make a tool that accesses this integrations page or the integrations repository, can find what's the relevant tool for the given user request, and try to actually run it. So very, very powerful things you can imagine. Whenever you want to combine multiple things, it's good to have multiple tools. And with that, I'd say I'm very much looking forward to tools implemented by you. Let us know on Discord when you have any questions about implementing tools. The slides and all the links here we will obviously share with you. And then from my side, I will already say thank you for joining this webinar.
Thank you, everyone. I think we'll call this a day. Birgit has just shared the Discord invite link. If you do have any more questions, please don't hesitate. We're pretty much 24/7 there, although maybe I shouldn't say that. We're there within our time zone limits. But keep an eye out for the next Haystack webinar, and thank you for joining. See you next time.
See you.